Despite having discovered just a tiny fraction of all of those billions of exoplanets that we think that exist, how could we know how many of them could harbor life? In astronomy and astrobiology, the region around a star where a planet with sufficient atmospheric pressure can maintain liquid water on its surface is known as the circumstellar habitable zone.
The habitable zone is a place, it's kind of a way of thinking about the right way to go look for planets like our own.
The Earth is obviously in the circumstellar habitable zone of our solar system. A potentially habitable planet implies a terrestrial planet with conditions roughly comparable to those of Earth, and thus potentially favorable to life.
There's a sweet spot, an area where it's not too hot and not too cold, and we call that the habitable zone, or some people call that the Goldilocks zone. If you've got a planet in that regime, and if it's small, if it's rocky enough, and it had water, that water would be in a liquid state, more than likely. So that would be a good place to go looking.
On November 2013, astronomers reported, based on Kepler space mission data, that there could be as many as 40 billion Earth-sized planets orbiting in the habitable zones of sun-like stars and red dwarfs just in our galaxy, the Milky Way, 11 billion of which may be orbiting sun-like stars. Those 11 billion exoplanets orbiting stars like our Sun really are a huge number of potential Earth-like worlds. However, now we know that stars very different from our Sun may be a good place to look for life. In May 2016, a team of astronomers announced, for the first time ever, the finding of 3 habitable planets orbiting a star completely different from ours, an ultra-cool dwarf star. It's the first planetary system found around a star like this. The star, named TRAPPIST-1, is just 40 light-years away and is much cooler and redder than the Sun, and barely larger than Jupiter. In fact, stars like this are very common in the Milky Way, and they are very long-lived. The 3 planets are very similar in size to the Earth and might have habitable regions on their surfaces. So the answer to what the best place in the universe is to find life nowadays has radically changed. To date, among all of the more than 1,000 confirmed exoplanets, there are around 50 that are in the circumstellar habitable zone of the star they orbit around. And therefore, they could be potentially considered Earth-like planets, which does not imply these distant worlds may harbor life. However, could life be possible outside those habitable zones? The discovery of hydrocarbon lakes on Saturn's moon, Titan, has begun to call into question the carbon chauvinism that underpins circumstellar habitable zone theory. Liquid water environments have been found to exist in the absence of atmospheric pressure and at temperatures outside the circumstellar habitable zone temperature range.
Just because a planet is outside the habitable zone doesn't mean that it couldn't have life.
For example, Saturn's moon Enceladus and Jupiter's Europa, both outside the habitable zone of our solar system, may hold large volumes of liquid water in subsurface oceans. If we are considering the possibility that life could arise in such harsh environments, which are not in the circumstellar habitable zone, that implies that we should look for exoplanets far beyond those zones. So the chances of finding an exoplanet with conditions to support life are much higher.